Hi everyone! Today we're going to be talking about pyramids and cones. Our objective for today is that students will be able to find lateral areas and surface areas of both pyramids and cones. Let's get started. Alright, so today we're going to start by talking about pyramids. Now, if you can recall, a pyramid is where we have a base and all the faces meet at a central point. Alright, so this would be a square pyramid because there's a square base and all the faces meet at this point up here. When we're talking about a pyramid, we have something called the slant height as well. So the height from the center to the top would just be our normal height of our pyramid. Now, the slant height is the distance from the point at top down to the base. So this line right here, the height of one of our faces of our triangle, this would be our slant height. Alright, so the slant height is very important when we're trying to calculate the surface area of a pyramid. Now, to find the lateral area of a pyramid, and if you recall, the lateral area is the area around the pyramid, not including the base. So to find the lateral area, our formula is 1/2 times the slant height times the perimeter of the base. Then if we want to find the surface area, which includes that base, so how much wrapping paper do we need to cover the whole pyramid, including the base? That would be 1/2 times the slant height times the perimeter of the base, so our lateral area, plus the base, the area of the base, okay? So let's find the surface area of each of these pyramids below on your paper. So let's start with number 1. First things first, let's identify all the information we need. So we're given that 11.7, and that's our slant height, all right, because that's the height of the triangle of one of our faces. Then we need to know the perimeter. So the perimeter of our base is this square where every side is 8. So the perimeter would just be 4 times 8, or 32. Then the area of our base, all right, which we want to say B, all right, the area of our base is just going to be 8 squared because the area of a square is side squared. So the area of our base is 64. Now we want to take our formula. We want to take 1/2 times slant height times perimeter plus the area of our base. Plug in our numbers that we know. So surface area equals 1/2 times our slant height, which we know is 11.7, times our perimeter, which we discovered was 32, plus the area of our base, which we found out to be 64. Then we let our calculator do all the hard work. All right, so 1/2 times 11.7 times 32. Plug that into our calculator, and we get 187.2 plus 64. So when we add 64 to that, we get 251.2. All right, and if you want to round to the tenths or to the hundredths, that's fine. All right, either one is okay with me. All right, but I need at least one decimal place here. All right, and we always say meters squared. Always have to include the unit, and since it's surface area, we say squared. And we're done. All right, now you may see a problem like number 3. And what's important to notice here is that we're given the height of our pyramid, but we're not given our slant height. And we need to know that slant height because we need our L. We need our slant height for our formula. All right, let's first identify what we're given. All right, we're given that this is a square pyramid. We know that every side is 16. So to find our perimeter, we would just say 4 times 16. So our perimeter is 64, right? Yep. Perimeter is 64. Now the area of our base. So our base is just going to be 16 squared. So the area of our base is 256. Now we still need to find that slant height. All right, so important thing I want you to notice, if I erase those little marks, we have the height. We know the distance from the center to the edge is going to be half of 16. It's going to be 8. And then our slant height goes from here to here, okay? We don't know what our slant height is, but we do know that our height of our pyramid is 3, all right? So this is 3 right here. Now, we've got a right triangle that we just drew. So anytime we've got a right triangle and we're missing a side, especially that hypotenuse, we can use the Pythagorean theorem to help us find it. So we would say 3 squared plus 8 squared equals L squared. 9 plus 64 equals L squared. 73 equals L squared. Take the square root of both sides, and we get that L equals 8.5. And we just found our slant height using the Pythagorean theorem. Now we want to take our formula for surface area of a pyramid and plug everything in. So surface area equals 1/2 times our slant height, which we just found using the Pythagorean theorem, times the perimeter, which we previously found to be 64, plus the area of our base, which we know is 256. Then we let our calculator do all the hard work. So 1/2 times 8.5 times 64 is going to give us 272. When we add 256 to 272, we get 528. And we're using feet squared. Always need our units squared. And we're done. All right, so number 5. Number 5 is a little different. The last two problems were square pyramids, right? This problem is a triangular pyramid. So our base is this triangle right here. All right, we are given our slant height. So 12.2 is our slant height. And then we need to find the perimeter and the area of our base. So first things first, to find the perimeter of our triangular base, this right here, all the sides equal 7. So 7 times 3, our perimeter is 21. Easy peasy. Now to find the area of our base, it's a triangle, so we want 1/2 times the base. And this 6.1 here is the height of that triangular base. So that would be our 1/2 base times height. That would be our height, 6.1. All right, then we let our calculator do all the hard work. 1/2 times 7 times 6.1. The area of our base equals 21.35. All right, now we got all the information we need. We've got our perimeter, we've got the area of our base, and we've got our slant height. Plug it into our formula. So surface area equals 1/2 times our slant height is 12.2. Our perimeter is 21 plus the area of our base, 21.35. Then let your calculator do all the hard work. So 1/2 times 12.2, and that's why you should have your phones off. Sorry, guys. All right, 1/2 times 12.2 times 21 equals 128.1 plus 21.35. So 128.1 times 128.1 plus 21.35, we get 149.45. All right, and we're dealing with centimeters, and it's squared, because we're talking about surface area, and that's our final answer. All right, now cones. Cones are pyramids that have a circular base. So when we're talking about cones, we've got our lateral area, which is the area around it, not including our circular base. And surface area is the lateral area plus the area of our base. All right, so to find the lateral area, our formula is pi times the radius times the slant height. And then to find our surface area, we want the area of the base, so pi r squared, plus the lateral area, so plus pi times r times L, or slant height. All right, and there's some cases where we may need to use the Pythagorean theorem because we've got a right triangle here to help us either find our radius or our slant height, okay? So if we're given number 7 and we want to find the surface area of this cone, this one, we actually love problems like this because we're given our radius is 7, and we're given our slant height, all right, is 11.4. So then we just take this formula and plug it in. Surface area equals pi times radius is 7 squared plus pi times radius times our slant height. Let our calculator do all the hard work. 49 pi plus 11.4 times 7 is going to give us 79.8 pi. Then 49 plus 79.8 is going to give us 128.8 pi. And you can really skip that step if you want. I'm just trying to give you the exact answer here. All right, so 128.8 pi would be your exact answer. But then we want to estimate, so we want to plug it in, go all the way. 128.8 times pi. It's going to give us approximately 404.64. All right, you don't need to go past the hundredths place and meters squared because we're talking about surface area. All right, and we're done. All right, number 9 is one of those problems that I was telling you about before where we're going to need to use the Pythagorean theorem to either find our slant height or our radius. So here we're given our slant height, all right, that's 27.3, and we're given the height of our cone, but we don't know the radius. So what we can do is look at it as a right triangle, solve for our radius here. So we would say r squared plus 25.2 squared equals 27.3 squared. 25.2 squared is going to give us 635.04. And 27.3 squared is going to give us 745.39. Then subtract 635.04 from both sides, and we get r squared equals 110.25. Take the square root of both sides to get r by itself, and r equals 10.5. All right, now we found our radius. We've got our slant height. Plug them into our formula. So, surface area equals pi times our radius we just found using the Pythagorean theorem squared, then plus pi times radius times our slant height, which is 27.3. Now 10.5 squared is going to give us 110.25 pi plus 27.3 times 10.5 gives us 286.65 pi. Add them together and you get 396.9 pi, so that would be our exact answer. But then we want to use our calculators and get an approximate answer, and we're going to get 1,246.9 inches squared. And that is the surface area of our cone. All right, now we're going to do our real-world applications. And like I had said in the previous lesson, these applications are so important because this is why we're learning all this. We want to be able to apply these formulas to real-world situations. So I'm going to do all of them, not just the odds when it comes to these application sections. All right, so if we have number 10, we have if a cone has so we're dealing with a cone, all right? Oh, let me get a bright color. We're dealing with a cone and it has a surface area of 822.78 centimeters squared. And we're given that it has a diameter of 18 centimeters. We want to find the slant height, all right? So that's what we're looking for of the cone. So first things first, we're dealing with a cone. So we want the formula for the area of a cone, or the surface area of a cone. So surface area equals pi times r squared plus pi times r times slant height. We're given that our surface area is 822.78, so we're going to plug that in for surface area. And we're given that it has a diameter of 18, so that means that our radius is 9. It's half of our diameter. So, equals pi times 9 squared. We're looking for the slant height, so we don't know what the slant height is. So we're going to plug in our r, and we're going to leave slant height as an L. So anytime you have a problem like this, start with identifying what formula you need, then plug in the given information, then solve for the missing variable. All right? So now it's just algebra, and we're solving for L. So 822.78 equals 81 pi plus 9 pi L. Then we want to subtract 81 pi from both sides. Let our calculator do all the hard work here. We do 822.78 minus 81 pi, and we're going to get 568.31 equals 9 pi times our slant height. Then divide both sides by 9 pi because we want to get that L by itself. 9 pi's will cancel out over here. Be sure to put parentheses around that 9 pi when you're plugging it into your calculator. All right, so 568.31 divided by 9 pi, and we're going to get that our slant height equals 20.1, and we're dealing with centimeters here, so centimeters, and that's our final answer. All right, number 11. So number 11, we've got this figure. It could be a small house, it could be a hut, you could be building a birdhouse. All right, we don't know what it is, but we want to find the surface area of it. So what you would need to do is break it apart into two separate figures because this is a cone and a cylinder. All right, so first we want to deal with the cone on top, and we'll call this figure 1. So just like last chapter when we learned about composite figures, we broke them apart into separate figures, found the area, then added them together. Same thing we're doing here, but with three-dimensional figures. So this cone on top will be figure 1, and we want to identify that the radius of this cone is going to be half of 34, so it's going to be 17. Then we want to find the surface area. So in order to find the surface area of a cone, we're going to use the formula pi times radius, which is 17 squared, plus pi times radius times our slant height, which we're given is 20, right? This is our slant height. Then let our calculator do all the hard work. So we get 289 pi plus 340 pi, add them together, and we get 629 pi. Now we want to leave it in terms of pi until the very end, because if we find out what 629 pi is now, round it, we're not going to get an exact answer. So we want to leave it in terms of pi until the very end, all right? So leave it as 629 pi is the surface area of our cone, figure 1. Now let's look at figure 2. Figure 2 is this cylinder. All right. For this cylinder, we want to use the formula for surface area of a cylinder. So for surface area of a cylinder, our formula is 2 times pi times our radius, which is also 17 squared, plus 2 pi r times the height. And we know the height is 12. All right. So then, let our calculator do all the hard work. 578 pi plus 408 pi. Still want to leave it in terms of pi, so we get 986 pi. That's the surface area of figure 2. Now, the important thing to recognize here is that we found the surface area of the cone. That's including the base, so including the circular base. And we found this, so that's including this circular base right here, okay? Let me get my highlighter. When we found the area of the cone, we included that surface area of the base of the cone. Then when we found the surface area of the cylinder, that also included that same base, all right? So these two numbers, 986 pi and 629 pi, include that yellow base, that circular base, twice. And if we're just covering the outside of this figure, we don't need the surface area of that inner circle because that's on the inside, not on the outside. So we don't want that circle. And with our two areas that we found, with our two surface areas, we found it twice. So what we need to do is find the area of that circle, multiply it by 2, and subtract it from our total surface area. So first off, let's find the area of that circle. So the area of this circle is going to be pi times radius, which is 17 squared. All right, so 17 squared is going to give us 289 pi, okay? So this equals 289 pi, and that's just the area of the circle once. Now, when we want to find the total surface area of the entire figure, what we're going to want to do is we're going to want to take our first surface area, the 629 pi, add our second surface area, the surface area of our cylinder, plus 986 pi, and then we want to subtract our circle, but we want to multiply it by 2 because we want to subtract it twice. So we want to subtract 289 pi twice. So this is our expression that we're going to plug into our calculator. So we plug in 629 pi plus 986 pi. Oops, sorry, I don't know what's happening here. Just trying to move everything around. Okay, I didn't want that box around there. Oh no. Okay, so we want to plug this into our calculator. Plug this black expression into your calculator. 629 pi plus 986 pi minus 2 times 289 pi. And that's going to give us our final answer. All right, so let me see if I can make room here. Move everything up. So the total surface area of our figure, when we plug that into our calculator, we're going to get 3,257.83. And we're going to say meters squared because it's surface area. Always got to give the units squared. And that is your final answer. All right, last but not least, number 12. So number 12, we've got a roof on a shed is a square-based pyramid. So when in doubt, draw a picture. Even if your pictures are terrible, like mine probably will be. All right, it's better than nothing. Always draw a picture. All right, so we've got a square pyramid. They meet at one point. And most importantly, we have that our base is this square right here. All right, if the base has a side length of 10 feet, and we know it's a square, so all the sides are 10. And it has a slant height of the roof, so that's our slant height, and that's going to be 9.4 feet, okay? We want to find the area of the roof. Now, because we're finding the area of the roof, we are not finding the surface area because we don't care about the base. The base is attached to the shed. We just want the lateral area, so we want the area of all the faces, which are the roof, of all the triangles. So we're going to use the formula for lateral area here. So the lateral area, because we do not care about the base, is 1/2 times the, not height, times the slant height times the perimeter, okay? So our perimeter, first of all, 1/2 times our slant height. We're given that it's 9.4. Our perimeter is going to be, add all the sides together, so 10 times 4 gives us 40. Then you let your calculator do all the hard work, 1/2 times 9.4 times 40, and you're going to get 188 feet squared. So the important thing, especially with this problem, is to read it very carefully, understand what the word problem or the application problem is asking you to find. So in this case, it's asking you to find the lateral area because we do not care about the base, we just care about the roof. All right, just that lateral area. All right, so if you have any questions about cones or pyramids and finding the surface area, please call me over so I can help you out. But I hope you learned a thing or two about finding the surface area of these figures today. Please look to the board to see what to do next, and I hope that you have a great day.